Assalamualaikum and good evening, everybody. My name is Nur Husnina binti Azad. I'll be presenting my final year project on effect of heating feed on thyroxine immersion on the molting of horseshoe crab Tachypleus gigaslavi. During my project, I've been supervised by my beloved supervisor, which is Dr. Annie Christianus. So this is my table of content. And okay, out of four living horseshoe crab that can be found in the world, there are actually two horseshoe crab living in Malaysia, which is Tachypleus gigas, the coastal horseshoe crab, and the mangrove horseshoe crab, which is Carcinoscorpius rotundicauda. Okay, according to the IUCN, animals such as sponges, mud crabs, mussels, and snails use the large hard shells as their microhabitat. This is why horseshoe crabs are practically is one of the vital links to the coastal biodiversity. According to Button and Shin from in year 2020, it is actually that these two Asian horseshoe crab species will soon be listed on the IUCN red list. This is because the horseshoe crab numbers are decreasing rapidly all around the world due to different factors such as water pollution, the loss of their habitat for living and also spawning, and not to forget the overharvesting of the adult horseshoe crab. Okay, for my problem statement is first, scarcity of report on larviculture, especially on feeding rate effect on the growth of Tachypleus gigas larvae. And next, there is actually no report at all on the effects of thyroxine hormone on the molting of Tachypleus gigas larvae. So this is my objective, which is to determine the average number of Artemia nuclei consumed by the horseshoe crab's larvae per feeding. And second objective is to observe and determine the effect of thyroxine T4 hormone immersion on the molting of horseshoe crab larvae. So move on to the literature review. Tachypleus gigas comes from the phylum Arthropoda, which is very familiar and popular with its hard shells of exoskeleton. Comes from family Limulidae. And genus Tachypleus, hence the name of species of Tachypleus gigas. Then this species usually found in both east and also west coast in Peninsula Malaysia, and they prefer to live in sandy and muddy condition. This species does not really tolerate a low salinity. Thus, they actually need sandy beaches with high salinity in range between 30 to 32 ppb. So, for the behavior of this species, the adult horseshoe crab migrate from the offshore continental shelf to spawn on the intertidal sandy, and they will come to the beach every full moon and also new moon phase. All right. For their feeding behavior, Tachypleus gigas actually a very selective is a selective feeder, as shown to be has been analyzed in their gut. Usually, they prefer to eat mollusks and decayed organic matter. However, so there is study based from conducted by Mishra 2009 in a controlled condition in lab in lab condition. Trilobite of T. gigas can be cultured with controlled diet of brine shrimp Artemia and diatom, which is Cetiocerus gracilis. And the average total length of freshly hatched trilobite larvae, which the one that does not possess any tail, will be around 8 millimeter. And the average growth from the first to second post-hatch stage, the growth rate will be around 63%. So, the thyroxine hormones actually plays an important role process of metabolism, absorption, and absorption of the yolk sac and fish growth. So, this is the reason why I'm using this thyroxine hormone in my project. Okay, this is my methodology. The horseshoe crab eggs were actually collected from the wild at the sandy beach at Kampung Batu Lapan, Tanjung Sepak Banting Selangor on the 80th August of 2020, along with Dr. Annie. So, okay, for my sample and feed preparation, after the eggs collected from the beach, we actually collect 4 batch of eggs that were sampled and washed with filtered seawater and also fresh water respectively over and over to make sure to remove all the sands and debris that attach to the egg till it's clean. And most eggs that we use in this experiment is hatched between 50th September till 20th September 2020. So basically, my experiment was conducted at the Institute of Bioscience, IBS, at Hatchery, University of Putra Malaysia. So how do I prepare my treatment materials is for experiment one, there is three treatment, and what treatment one, treatment two, and treatment three, and each treatment will be using three petri discs each. And for experiment two, well, for dosage, three treatment with tyrosine concentration, which is 0.5 ppm, and 1 ppm. And so another factor for 0.5 and 1.0, which is the number of emission, which is one time, two time, and three time. And each of these factors have three replicates each. Water exchange is done every 2 days. So my preparation of the artemia for general feeding. Um, I've been using a conical bottom as hatching tank. It was clean and filled with filtered seawater. And the salinity required is between 15 to 30 ppt, and temperature is around 25 to 30 degrees Celsius. In average, I've been weight 0.12 gram eggs were hatched between 24 to 36 hours. So, okay, this is my experimental design for my first experiment, which is feeding rate experiment. As you can see here, each treatment have three replicates, and each petri dish have 5 horseshoe crab larvae. So Artemia hatching was carried out every once in 2 days using Artemia egg with a weight of 0.1 to 2 gram, and in a 500 milliliter of sterile and filtered seawater. And so in treatment one, Tachypris gigas larvae in each petri dish will be 500 Artemia nuclei. For treatment two, will be fed 750 Artemia nuclei, and treatment three will be fed 1,000 Artemia nuclei each petri dish. Okay, for the second experiment, which is dosage and number of immersion of tyrosine experiment. So the three treatment for tyrosine concentration is the control 0.5 ppm, and 1 ppm. So for this experiment, I have to prepare the tyrosine hormone solutions. So tyrosine was I prepared the tyrosine hormone at the laboratory in our faculty in aquaculture department. So tyrosine was weighed and dissolved in 1 liter of sterile and filtered seawater. The concentration of P4 prepared is 0.5 and 1.0 ppm. So the pH of the solution was adjusted between 8 and 8.5 by using sodium hydroxide using the pH 700 meter. Okay, as you can see, that is my how I lead my experiment. The blue color is actually with the dosage of 1 ppm, yellow is 0.5 ppm, and the green one is the control. So for 0.5 and both 0.5 and 1 ppm has the different number of immersion, which is 1 time, 2 times, 3 times, and 3 times. So the data collected is from 9th of November till 50th December. The first time immersion will held on 9th of November, and the second time were on 60th November, and the last immersion was on 23rd of November. Okay, so how do I analyze my data is by using IBM SPSS statistics version 25. So for experiment one, I've been using one-way analysis of variance of one-way ANOVA because I have only one factor to analyze, and using two key new multiple range tests for my post hoc. And for my second experiment, due to they have actually two factors, therefore I'm using two-way analysis of variance, two-way ANOVA. Also with two key new simple multiple range tests. So this is my result for my first experiment. As you can see in the table, there is a feeding rate of number of Artemia, feeding rate, number of Artemia nuclei / feeding, and percentage of larva molted. So the data here already displayed in manners of mean plus minus with standard deviation. Before that, I already transformed my data to arcsine form. So therefore, after I've run the analysis, there is actually no significant difference as their p-value is much more higher than 0.05 on on the percentage of molted horseshoe crab larvae were observed between all feeding rates. So, and my second experiment, um, also this, it was uh, the data was transformed to Axine form, uh, to Axine, and it is shown as mean plus minus with standard deviation. And this experiment too shown no significant difference as their p-value is higher than 0.05. So there is no significant on the percentage of molted horseshoe crab larvae observed between all treatment and also all treatment for different T4 concentration and also the number of immersion. Alright, based on experiment 1 result, the different feeding rates using Artemia showed no significant difference on the percentage molted Tachypleus gigas larvae due to they actually have no effect on the growth. All three feeding rates showed similar growth, indicating that feed, even though it's at 750 and 1000 nanoply per feeding, seems to actually be over its limit for the feeding capacity, and of and also meaning that it's not actually an optimal rate for Tachypleus gigas larvae. And so therefore, from future research, it is possible to look into reducing the number of Artemia species nuclei per feeding to determine the optimal rate for this horseshoe crab larvae. Okay, for experiment 2, okay, first we talk about the first factor, which is the difference of T4 concentration. So it actually showed no effects on its growth. Thus, of course, there is no significant effect on the percentage of molted Tachypleus gigas larvae. So T. gigas comes from the, as I mentioned earlier, comes from the phylum Arthropoda, species that is hard as a skeleton. So this physical feature might contribute to have the limits of to maybe the limits of absorption of T4 during immersion. Even they have different dosage of T4, it still doesn't show any significant difference. Even when given concentration that actually contribute to enhancement or even inhibition of growth, like other species, which is pink zebrafish larvae, Brachydinurero, as said by Arifianto Hardy, Slamet Budi Prayitno in the year 2018. So this study conducted to determine whether T4 can spread up to speed up the growth of horseshoe crab. As it is, the horseshoe crab takes about 9 years to reach the puberty. Therefore, if the growth can be significantly enhanced, and then to culture the species may be viable for other people. So for the other factor, which is different number of T4 immersion, result of also resulted in no significant difference on its molting process of Tachypleus T. gigas larvae. Similar to the dosage experiment, the hard shell of horseshoe crabs hinders the absorption of hormone efficiently into the body as compared to other species. So for further investigation need to be carried out if immersion duration can significantly contribute to enhance of growth of this horseshoe crab. Maybe longer duration of immersion may help more the hormone to even penetrate the shells better. At one um, at 1 ppm of T4 can actually inhibit the growth or even worse, increase the mortality of fish fry, as stated by diseases Toledo and Sipas by the year of 1998. But however, it shows that this concentration shows no adverse effects on the horseshoe crab larvae. And thus, as the hormone is costly, using this T4 actually at high concentration is not economical. Therefore, for the further study, it is possible to experiment on the length of time length time of immersion of the hormone T. gigas larvae. So in my conclusion, feeding rate of at 500 till 1000 Artemia nuclei per feeding and T4 immersion at 0.5 to 1 ppm does not affect the growth of Tachypleus gigas larvae. So this is my reference. Okay, thank you.